Welcome to this video on solving equations with variables on both sides of the equation. So we're delving deeper into rules and procedures of solving equations. So first we did one-step equations and then two-step equations. Now we're starting to do multi-step equations. Remember, our goal is always to isolate our variable. So again, we always draw this vertical line so we keep the two sides of our equation straight. Then we ask ourselves, what is being done to the variable and how do we undo it? Well, that's a little bit tricky because we have variables on both sides of the equation. We have a 5x over here and a 7x over here. So how do we proceed? How do we isolate our variable when we have variables in two different places? And the answer is that we want to move our variables to one side of the equation. And remember, the way we move things across that barrier or vertical line is by doing the opposite. So if I have a positive 5x, then I would undo this by subtracting 5x from both sides. Now notice, instead of subtracting 5x from both sides, an equally valid thing to do would be to subtract 7x from both sides. But, however, I would suggest when you do that, a really good hint is to try to keep your coefficients positive. Okay, that's a really good goal. The other thing is, if we did it this way, we would have negative 2x plus 2 equals 0, and then we would actually generate extra steps in solving this equation. So again, there are many right ways to do something. I'm going to try to show you guys the most efficient way to do things, and then you can, again, if you come up with a different way of doing things, that's fine, just as long as you follow the rules. So let's try subtracting 5x from both sides. So 5x minus 5x is 0, we bring down the 2. 7x minus 5x is 2x. And then, what's happening to our variable? Well, the only thing that's stuck to it now is the 2. 2x means 2 times x. We undo multiplication through division. 2 divided by 2 is 1, so we get x equals 1. And remember, just like all of the problems in the past, we can always check our work. So we have 5x plus 2 equals 7x. So 5 times 1 plus 2 is equal to 7 times 1. Right, so we have 5 plus 2 equals 7, or 7 equals 7. So our math checks out, and 1 is the correct answer. Let's look at some more examples. In this next example, again, you can see that we have 7x on one side and minus 2x on the other. So remember, our goal is to move all the variables onto one side of the equation and then move all the numbers to the opposite sign. And remember my hint, right? This isn't something you necessarily have to do, but it's really going to help you. Try to keep your coefficients positive. So, which side should we move our variables to? Let's draw our vertical line. Okay. So again, if I could subtract 7x from both sides, but hopefully you see that would give me a negative coefficient. So while that is correct, it increases the probability of me making a sign error. Therefore, instead of doing that, I'm going to try adding 2x to both sides. Again, both are equally mathematically valid approaches. So 7 plus 2 is 9. So I have 9x minus 6 equals 5. Then I would have to add 6 to both sides of my equation. So we get 9x equals 11. Last but not least, I have to divide by 9. So remember, in a previous video, we discussed that we prefer our answers. In fact, we mandate at times that they have to be a fraction, even if that fraction is improper. So we do not want decimal answers, and we do not want mixed numbers. Okay, we only want our fractions, our answers as fractions, even if they end up being improper fractions. And one of the reasons that we do that is so that when we check our work, it actually becomes a lot easier. So let's say I have 7x minus 6 equals 5 minus 2x. Okay, I could put 11 over 9 in both of these places. Now, I'm not going to lie to you, this is going to be a little bit more work because we do have fractions in here, so it's going to take a little bit of extra time. So 7 times 11 is 77. So we have 77 over 9 minus 6 equals 5 minus 22 over 9. Okay, so we need to make sure we have common denominators here. So in order to do that, what we have to do is multiply 6 by 9 over 9. So 6 times 9 is 54. 5 times 9 is 45. Okay, so 77 minus 54 is, I believe, 23. Okay, so this gives me 23 over 9 equals 23 over 9, and it checks out. Okay, let's do another example. So this time we have 12 minus x equals 6 plus 3x. Okay, again, our goal is always the same. We want to get all of our variables on one side of the equation, and we want to get everything else on the other side. Okay, and again, a hint is to try to keep your coefficients positive. So to keep my coefficients positive, the best approach is probably here to add x or 1x to both sides. Remember, if there's not a number, if there isn't a coefficient, the coefficient is just 1. So these go away. We get 12 is equal to 6 plus 4x. Okay, so now what we want to do is we want to, again, trying to isolate our variable, we want to leave our variable where it is and move things away from it using reverse order of operations. So 12 minus 6 is 6, so we have 6 equals 4x. Then we need to divide by 4. So if we leave our answer as 6 over 4, will we get full credit? And the answer is no, because you are always, always, always required to reduce fractions wherever possible. So my final answer here is x equals 3/2. And again, just as always, you can put that back into your equation and check your answer and prove to yourself that this is the correct answer. Okay, let's do one more example. So we have 3 plus 5x equals x minus 3. So again, I'm going to draw my line here. Okay, so remember, the first thing I have to do is I have to get all my variables on one side. The way I'm going to do that is to subtract x from both sides. So that's going to give me 3 plus 4x equals negative 3. Okay, so now my x is here. It's being multiplied by 4, and then 3 is being added to it. So again, we undo that in reverse order of operations. So first, we subtract 3. So this becomes 4x equals, well, what is negative 3 plus negative 3? The answer is negative 6. Then we divide by 4. We get x equals negative 6 over 4. However, we can reduce that, and it becomes negative 3 over 2. Okay, and I didn't check the last problem simply because I just completely ran out of room on that screen. So let's check this one for good measure. We have 3 plus 5 times negative 3/2 equals negative 3/2 minus 3. So that becomes 3 minus, or plus negative 15/2 equals negative 3/2 minus 3. So what we're going to have to do is multiply these whole numbers by 2 over 2. If it makes you more comfortable, you can put that over 1. So we get 6/2 minus 15/2, oops, sorry, not 12, equals negative 3/2 minus 6/2. So 6 minus 15 is negative 9. So we get negative 9 over 2 equals negative 9 over 2. Okay, and our math checks out. It is correct.